Hi, my name is Anderson Carniel and I'm an assistant professor at the Federal University of São Carlos in Brazil. I'm going to present you the systems paper entitled Handling Fuzzy Spatial Data in R using the FSR package. Several specialized software packages provide sophisticated library support to represent, manipulate, and process spatial information. Some examples of such software packages are shown here. These software packages implement spatial data types for representation of crisp point, line, and region objects and include several geometric operations. Crisp spatial objects are characterized by an exact location and a precisely defined extent, shape, and boundary space. There is an increasing interest in modeling and analyzing spatial phenomena characterized by the feature of spatial fuzziness. Fuzzy spatial objects have inexact locations, vague boundaries, and/or blurred interiors. The central idea is to relax the strict decision of belonging or not belonging of a point to a spatial object. Instead, partial belonging is allowed and expressed by a membership degree in the interval between 0 and 1. For example, we can distinguish situations where a temperature value is characterized by linguistic values such as cold, warm, or hot. Hence, in this example, our variable is the temperature level that can assume different representations. In the image, we are showing the hot temperatures locations in Brazil. Unfortunately, there is a lack of complete implementations of software packages that can handle fuzzy spatial objects. Motivated by this, we introduce an R package named FSR that provides an implementation of fuzzy spatial data types and their operations, builds spatial plateau objects from real data sets, allows users to conduct exploratory spatial data analysis, provides support for fuzzy spatial inference models to discover new finds from fuzzy spatial objects. FSR is publicly available at CRUN in this link. CRUN is the official repository for packages written in the R programming language. This means that users can easily install FSR by executing the following command. Here is the architectural overview of FSR. Applications like SDBS, Spatial Database Systems, Geographic Information Systems, Spatial Data Science projects make use of the FSR package by calling its functions. We employ other R packages to implement FSR. Some of them are shown in the bottom layer of this figure. To illustrate how FSR works, we build up a small application based on two real spatial data sites, Airbnb accommodations in New York City and New York City restaurant inspection results. Each dataset contains crisp point objects labeled with several alphanumerical attributes. Each attribute is represented as a linguistic variable with a set of linguistic values that characterize the situations of the attribute. For example, the first one represents the daily price of the accommodation and its linguistic variable is named the accommodation price, which can be characterized as cut rate, affordable, and expensive. One goal of our application is to design a fuzzy spatial inference model to estimate the visiting experience based on prices and overall ratings of accommodations, as well as sanitary conditions of restaurants. Thus, we also define the linguistic variable visiting experience. We classify an experience as awful, average, and great. In this first program, we shows a small example that uses some basic functions of SR to create fuzzy spatial objects as spatial plateau objects. It starts by defining a set of matrices containing the coordinates to build crisp point objects and crisp line objects. Next, we create two components for this CRISP objects. A component consists of a CRISP spatial object and a membership degree between 0 and 1. In this case, we employ the package ESF to deal with CRISP spatial objects in FSR. Then the program builds a plateau point object and a plateau line object. The class implementing a spatial plateau object in FSR is called pGeometry. Here are two examples of spatial plateau objects. We show them by using textual and graphical representations. This is the second program employed in our running example. The goal is to build a set of plateau region objects that characterize the linguistic values of each linguistic variable. Here, the code is not complete. It shows only the construction of the plateau region objects for one linguistic variable. This linguistic variable is the accommodation price. So here we first create a character vector containing all the linguistic values of the accommodation price. Then we express the meaning of each linguistic value by defining membership functions. In this example, we employ the trapezoidal membership functions. Next, we call SPA-Creator to build plateau regions by taking a comprise, which is a data frame, as first input. The SPA-Creator implements a two-stage construction method that builds fuzzy spatial objects from a set of point objects. More details about this method is given in the paper. The result is a data frame containing a pGeometry object for each linguistic value of the input of SPA-Creator. Here, we can visualize them by using the function plot. So this is the result. Here is the plateau region object for the linguistic variable accommodation price. Note that we have one plateau region object for each linguistic variable. For instance, this object represents the cut rate accommodations. This one represents the affordable accommodations, and this one represents the expensive accommodations. This means that, for instance, here, a particular location, actually this will be a component within an area. With a membership degree equal to 1, like this, represents the coverage area of an accommodation whose price is between 48 and 8. Since the trapezoidal membership function for the linguistic value affordable returns 1 for these values. So this is the relationship between the employ of the fuzzy sets and the build plateau region object. The FSR package provides several fuzzy spatial operations to manipulate the spatial plateau objects. In this example, we assume that all plateau region objects of our running example is built. In this program, we use fuzzy intersection to discover to which extent the locations have expensive accommodations and restaurants with high food safety, as shown here. So we get these two plateau region objects and make the intersection between them. FSR also provides support for fuzzy spatial inference models that are modeled to discover new findings from fuzzy spatial objects. A fuzzy spatial inference model can be subdivided into a preparation phase and an evaluation phase. Here is the code for preparing the FSI, which stands for the fuzzy spatial inference model for our running example. The evaluation phase of FSI models can be performed by using two functions. The first one is the FSI eval, which infers the reasoning conclusion for one single point location. It employs fuzzy logic to make the inference. So this means that the input of this function is a single point. The next function evaluates the query window inference, a new type of inference introduced in this paper. The goal is to allow the user to specify a window of interest to answer questions like, return all the points with inferred values belong to a target linguistic value of my application. In our running example, we want to capture all the points with great visiting experience. For this, FSCR implements two approaches. One is based on regular grids, and the other one is based on the particle swarm optimization. In this paper, we have introduced a new R package named FSCR that allows users to construct spatial plateau objects from real datasets, conduct exploratory spatial data analysis by deploying spatial plateau algebra operations, design fuzzy spatial inference models to get new insights from spatial plateau objects, optimize the inference process by applying the PSO algorithm. Future work will deal with a number of topics, such as design of optimized techniques to implement spatial plateau operations, and more studies on the query window inference approaches. We invite you to use and explore FSCR. Thank you very much for your attention, and feel free to make questions or also contact us by email. Thank you very much.